Hi, sir.
Hello, Haripriya. SHM part we have done in the last class. Acha, concept wise this is over. Let me give you some questions to solve, and there were few cases that I was going to tell you. Conical pendulum and torsional pendulum. In the last class I was telling you about this one, no? They will join. They're not punctual. In the last class, I was telling you about this case, na? When a tunnel is dug along the chord of the earth, what happens then? That I will explain. See, this is your earth. Now, in this particular case, the tunnel is along one of its chord. Like this. This is one. What is this? Like this. The tunnel is like this. I have tried to draw it parallelly, but it's not done parallelly. Let's see. Okay, this is the mass M. And now what's there? When you take this case, now, if you take this distance as what? If you take this distance as y, this is y. Suppose this distance is x. Okay. Now we know that the gravitational force of attraction will be towards this direction, this force, and this force is given by minus g capital M small m by y square. No, sorry. It's not like that. Field is there now. We have to calculate the field at this point, and then that field has to be multiplied with the mass. So if we calculate E field is equal to force upon small m. So F will be equal to E into m, and the field at this point, if you see, it will be G capital M by R cube into Y. Okay? This result you should know.
No, yeah.
You do not know that field one.
It should be R square.
No. The field is G M by R cube into small r. Actually, if let me show you that result. If this is the earth, na, solid earth, and you want to find out the field at this point at a distance of r, if the radius of earth is capital R, then the field at this point r is given by this formula. Field E is equal to minus G capital M by capital R cube into small r. This is the formula for solid, because it is solid earth.
Sure.
Yes, no? That's in the same way, because the radius of the earth is capital R, then in this case gm by capital R cube, because the radius I have taken as y, small y, that's why I put it small y into small m. I'll do this force minus g capital M by capital R cube into small y to small m. So I can write force as minus g capital M small m by capital R cube into small y. Now, since the SHM is taking place in this direction, this way, like this, to and fro, this way and this way, along this, like this. So we have to take the force component along this direction. If we take this angle, if suppose if I have taken this angle as what I say, if I have taken this angle as theta, this angle as theta, in that case, what will be the force which is required for SHM in this direction? It will be F cos theta. We are not concerned with the vertical component of sin theta, only because this F cos theta will be responsible for doing SHM. So F cos theta will be minus G capital M small m by capital R cube into Y into cos theta, right? So what is cos theta? X by Y. So that's why the force restoring force of cos theta is this. Now if you come, this is the force, this you have to equate with minus m omega square x. So get cancelled, x will get cancelled. Gm by capital R cube is equal to omega square. So your omega is equal to root over capital Gm by R cube. So T is equal to 2 pi by omega. That's why you get 2 pi root over R cube by Gm. Same thing. What was the result? Where it is gone? The result was 2 pi root over R cube by Gm. Na earlier case, tunnel is dug along the diameter center. Now in this case, if the tunnel is dug along the chord, then also we are getting the same result. You understood? Just try to see how I did it. And if you have any doubt, ask me. Haripriya, okay?
Yes, sir.
Diva, okay?
Yes, sir.
Kanishka joined late. Kanishka, देख लेना इसको, है ना? This is the case of a tunnel is dug along the chord. Then the force which is responsible for doing SHM is actually the component F cos theta. This is a force F. So the result is actually, what result you need to remember, whatever tunnel in whatever direction along the earth you do, you are going to get the same result for the time period. It won't change. Now let me teach you about the conical pendulum. First, understand what is conical pendulum. It's not the same as the simple pendulum that you have actually. The conical pendulum is like this. Like this, it's the bar is there. Here it is present, and from here, what they do, actually this page has got its limit. Oh, we'll have I have to change it. Here's the page. Hmm. Okay, let me change the page. But it's hanging. Not work fine. Hmm. Conical pendulum. What is this conical pendulum? It's like this. Here, it's supported from the bottom. And from here, if you see, there will be thread with a ball attached to it. Now, what it will do when it will rotate now, it will do the circular motion like this. You can visualize it. It will be rotating like this, like this. Yes, correct. Okay, this is called as the conical pendulum. Now we are given the length L of this thread. Mass is given m. So at any time, if you see, mg will be acting downwards every time. Now you have to find out the time period of this. Can you find out the time period of this conical pendulum? Haripriya, Diva, Kanishka, do you have any idea? How do you find the time period of this? See, one hint I can provide you. Hint is, since it is rotating about this point, omega, if you can find out omega, time period will become 2 pi by omega. Omega is what? It's an angular velocity. Somehow you have to find out the value of omega. And you can use the concept of equilibrium and the circular motion equation to find out the value of omega. Assume that it is making an angle of theta with the vertical. Just think and tell me whether you can do it or not. What happened? Getting the idea? Not? No idea? See, let me tell you how we do it. It's not difficult. Easy only. See everyone. There is a tension force acting along the string. So if we, this direction if we take, this angle is up angle is theta, so this angle will also be theta. So this force will be T cos theta and this force will be T sin theta. Now, since it is in equilibrium, vertical equilibrium, it's not falling down. So I can write this equation. There is the equation as T cos theta is equal to mg, one equation. Also, since T sin theta is responsible for it to do the circular motion, so T sin theta will be equal to m into this distance. I do not know what this is, m into r into omega square. But anyway, I can find this out because r will be L sin theta. R by L is sin theta. L sin theta into omega square I can write. Okay. Now, I can cancel this out. So T value I have got m into L into omega square. I'll put this in the equation number 1. What I'll get? ml omega square into cos theta is equal to m into g. So got cancelled. So omega square is equal to g by L cos theta. That means omega I am getting as root over g by L cos theta. And so the time period we have got as t is equal to 2 pi by omega, which will be 2 pi root over L cos theta by g. Let's check the result whether I'm getting. Correct. If you have solved it, just compare the result. If you have not solved it, just see how I have done it. This is known as conical pendulum. Okay, what happened? Everyone is silent.
Yes, sir, I understand.
Understood, no? This is known as conical pendulum, the pendulum which makes a cone. Haripriya, okay, na? Tanisha, okay?
Yes.
Okay. Now the last one I'll tell you. After that, few oscillations of fluids are there that I'll teach you in the fluid mechanics when I'll teach that. Torsional oscillation also I'll tell you. After that, we'll start to do problems. See, first let me explain you what a torsional oscillation is. You may not have observed this kind of phenomena in your life because there were toys during my times on this concept, but nowadays I don't think the toys are there like this, because nowadays most of the toys that I see are actually electronic. They are battery operated, so waste. See, let me tell you what it is. This you have to visualize. This is a plate on the palm of my hand, and from which there is a thread. This is the thread which is holding it from the top. It's attached at the middle, holding it like this. Okay. Now what a torsion is, if I make a line, this is a point A, and if I try to rotate this, it will rotate it to this point A dash by making some angle theta. Then what will happen if I release it? It will try to do oscillation in this way, like this. Okay, able to visualize it? Yes, Diva.
So is it like that? So like जिस टॉय में हम इसे रोटेट करते हैं एंड फिर वो हम इसे रिलीज करते हैं तो वो ऑब्जेक्ट आगे जाता है एंड वो डायरेक्ट पीछे
हाँ
रोटेट।
हाँ 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 हाँ, सेम वन वही 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 है, और टॉर्शन। बट उसके केस में क्या होता है ना, इन दैट केस व्हाट इज हैपनिंग, in that case when you pull that and then release it, it throws away, then does not come back. In this case what will happen, when you pull it and then release, it will try to rotate like this, go the other side, and then again come back, then come to this side, then again move back, then again move to other side, move back, like this it will be rotating. Okay, that way. That's also some kind of torsion. You understood it right? Okay, if you are able to visualize it, it's okay, right? And this one is not difficult. In this case, actually torsion is not there in your syllabus, because torsion is not there because there is a whole book written on torsion. If you take mechanical engineering as your subject of in engineering, you'll get this torsion in detail. But in your syllabus, you have to just understand, when you rotate it by an angle theta, it's actually very similar to the spring force. F is equal to minus kx is there now. In the case of spring, in this case, the torque, whenever we rotate something like this and there is a rotational spring action, then in that case, this is C minus C into theta. The equation for this torsion kind of thing is torque is equal to minus C into theta. Okay. It works like spring in the rotation way. It works like spring in rotation. Understood? If you do not understand well, then also no problem, because this is not a very important thing. There in your syllabus, that's why I told you. But you won't get questions on this because it's half syllabus. This is half taught. So if you want to get the angular frequency of this, what you have to do, because torque is torque, we know torque is equal to I alpha, we have to do if doing SHM. So it will be I into d square theta by dt square will be equal to minus C into theta. So you have got d square theta by dt square is equal to minus C by I into theta, and you know you equate it with minus omega square theta in the rotational SHM. So omega square we are getting as C by I, and omega is equal to root over C by I. So time period will be equal to 2 pi by omega, which is 2 pi root over I by C. Okay, this is the thing. Only this thing you need to remember. This one. In torsion, the torsion is actually like the torsion is like, see, suppose I have this pen. This pen is not elastic. If I keep fixed one end and try to rotate the other part, it keeps on rotating. If it is torsional, and when I release it, it will rotate back and comes to its original position. That rotating is torsion, and when it comes back, it sits. This is its spring action. And the torque with which it tries to come back, that's given by minus C into theta, where C is torsional constant. Like you say, na, K is spring constant. That way. Okay, now let's solve some question, because actually, you know, SH a few other cases which are left in SHM are fluids in SHM and SHM in SHM of piston in thermodynamics. Just remind me when I teach these concepts to you, these topics to you. Fluids in SHM and SHM of piston in thermodynamics. When I teach you fluids in thermodynamics, if you want to learn fluid, you can watch the recording also. It's present in your, I think, so it's not present for you. So let me give you questions now. Let's start with the easy one and then move on to the tougher one. Acha, can you do this one? Already existing result is required for this. Attempt this.
The 10%.
10%. Oh. 10% only. Very good. Shall try to solve this question. Did everyone get the answer?
Oh, same thing.
Okay. Taking so much time. Hmm. Try this. Figure 1 shows one than figure 2. There are two figures. Where are the figures, right? Hmm. Hmm. These are the figures.
So for the previous one,
Hmm.
so can you tell the formula once again? I think I'm using the wrong formula, but I'm not getting.
The formula you should use here is 2 pi root over L by G. It's simple only. See, I'll tell you.
Two.
Hmm. Wait. 2. See, the formula that you should use, correct. Haripriya, you are correct. See, the formula that you should use here is 2 pi root over L by G. The length of the pendulum is increased by 21%, right here. So because 2 pi and G are constant, T1 is equal to root L1, T2 is equal to root L2. So if we take it's proportional. If we take the ratio, you will get T1 by T2 is equal to root L1 by L2. Now what they are saying, length of the pendulum is increased by 21%. Means the L2 has become L1 plus 0.21 L1. 1.21 L1. Okay, so T2 by T1 is equal to root over 1.21 L1 by L1. So it will become root 121 by 100. 121 is what? 11. 11 by 10 will be 1.1. So T2 is equal to 1.1 T1. That means it is T1 plus 0.1 T1. So it's increased by 10%. ओके दीवा, समझ में आया?
Yes, yes, sir.
Okay, this answer is also she has got. The answer is 2. Acha, now let me give you some different kind of question to you. This is one more question and this is other question. Try solving this quickly. You should be able to solve very quickly. It's not difficult, but you should remember the formula. If you remember the formula, you'll solve very quickly. If you do not, it will be difficult for you. Because let me write the formula for you. The formula is T is equal to 2 pi root over M by K effective. K effective calculation you know. The question that I wanted to give you was this.
Hmm. Yes,
Okay?
I got it.
You got the answer. Na? Kanishka, what about you? Getting the answer? You want me to solve?
Yes, sir, I am getting the answer.
Okay. Try solving this one.
Sir, M by, option D.
Option D. No. No, no, no. Option D is wrong. Did you see both the springs have spring constant 2K?
Yes, sir.
So the effective spring constant that you will be applying here should be 4K. What will be the effective
Option C. Options.
options? You are saying option D, na? Option D is wrong. Correct option is C.
Yes, sir. I took just 2 Ks.
See why? It's actually very easy. Because if you displace, this is going to do linear SHM, and if you displace it by a distance of x right, then there will be a force towards left because of this 2kx, and because this left 2k has been expanded by x, there will be again a force 2kx towards the left. So the effective restoring force that it is having is equal to 4kx. So k effective, you can take it as 4k. Time period will be 2 pi root over m by 4k. 4 you'll take outside, root over m by k. So it will be time period is equal to pi root over m by k. This should be your answer. If you are wondering why did I apply the formula that I am using is T is equal to 2 pi root over M by K effective. Simple one.
Sir, I had a doubt.
Hmm?
Sir, when we were solving for series,
Hmm.
weren't we doing it 1 by 2k plus 1 by 2k like that?
But this is not a series problem, no? If both the two Ks, both the springs were on the same side, it was like series. See what is happening. It's the case. Suppose this is not series. If you displace the M by this distance x, there is a force due to the left spring 2kx towards left. And since the right spring has been compressed, due to this also there will be a force 2kx. So the effective force on M which is acting is 4kx. This system is like there is a spring, there is a mass M, and there is a spring which is attached to it like 4k, whose spring constant is 4k. This is not that case. That case was different. If I have given you this case M, this is one spring 2k, and this is another spring 2k, then that case will apply, the series one. Because in this case, if I'm displacing M by x, right, both the springs will be compressed. But in this case, one spring is being compressed and one spring is being expanded. So the effective force is the double of this. So it's behaving like parallel. Even though it looks like series, behaving like parallel.
Yes, sir. Understood.
Now try to solve this one. Put it side by side.
Sir, is frequency same as time period?
No, 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 no. Frequency is actually the reverse reciprocal of time period. Frequency is f1 by t, and its unit is hertz. You must have understood from this formula because they have given 1 by 2 pi na should be reciprocal of time period. That frequency they are talking about.
Sir, option C. Guys.
Option C. Very good.
Okay, I'm also getting this answer, but I just had one doubt.
Hmm.
Like, gravity will be acting on the spring, so won't its mean position be like a little downward, like down the inclined line, I believe?
Hmm. It may be down the inclined plane, but who cares? Actually, you are correct. It will be somewhat down. If this is a equal position, it will go down, but who cares? Because if this is the equilibrium position, a mean position by displaced by x naught, then you are correct actually. mg sin alpha will be acting downwards. So for this to equate, there will be two forces, 2kx naught, which will be equating it. So for equilibrium, if we talk about the equilibrium, 2kx naught will be equal to mg sin alpha, and the equilibrium position will be x naught is equal to mg sin alpha by 2k. But how it's going to affect? Because it's not going to affect, because anyway, if this is the equilibrium position now displaced downwards, as you said, even then it will do SHM na from about this position here and here. You actually found it correct. If they would have asked you what is the position of equilibrium, what's the equilibrium position, then this is how you have to find out the equilibrium position. Otherwise, nothing will change because only forces are changing. Mg sin alpha force is there. G actually in the time period, how do you arrive at the answer? Because in the time period, if we see, time period is never dependent on the acceleration. It's 2 pi root over m by k effective only. It's not dependent on the acceleration at all. So why do we bother about this g sin alpha or g cos alpha which is acting? Because it's not dependent on the acceleration. The only thing that we have to do is find the k effective, and k effective will be 2k. So it will be 2 pi root over m by 2k. And if frequency is required, frequency is a reciprocal of this, it will be 1 by 2 pi root over 2k by m. That's what you got the answer. Okay.
Yes, sir.
Acha. Let's see, can you do this question or not? This is somewhat a different one, but interesting one. Time is less, but let's see whether you can. Let's just try to understand this. Probably you will solve it at home. Actually, on SHM, there are very interesting questions which are asked. I could not give you all of them. See this one. Let's try to read this one.
What is the relation between amplitude and time shift?
Amplitude and time
Time.
period. No, there is no relation. Time period and amplitude है. अच्छा, there is no relation. Only the force m omega square x a m omega square x that you can have here. See, first understand the question. Did you understand the question? A mass capital M is attached to the spring which is fixed on the other side rigid support. The spring constant of spring is given. Mass oscillates on a frictionless surface with time period t and amplitude a. This mass actually they are talking about, this mass actually does move with the amplitude a. This is the equilibrium position, so it moves left by a, right by a. This is the amplitude. Now when it is at the equilibrium position, at the mean position, small m is placed on it. The new amplitude of oscillation will be what? How will you find? And what concept you will apply here? See, can we say this is a case of collision type case? In the collision, there was breaking of one mass into two. Here, one more mass is joining. And in the mean position, we know the velocity of this mass is v is equal to omega into a. Correct? Because in the mean position, this is the maximum velocity. Mean position has the maximum velocity. The velocity is omega into a, na? Yes, Haripriya?
Yes, sir.
Now, can we do the conservation of momentum here? Just before mass m, small m is placed on it and just after it is placed. So it will be mass into V1, m into V1 is equal to m plus m into V2. M into omega A, it will be m plus m into V2. Since omega they are saying it is going to be same, no? So V2 is equal to m omega A by m plus small m. Now in this case, things will change. V2 will be omega 1 A1, new amplitude. M A by capital M plus small m. You know, omega is root over k by m initially. But now two masses are added. So omega 1 will be root over k by capital M plus small m. You got it? So we'll get the result like this. Into A1 new amplitude is equal to m a by capital M plus small m into root over k by m. Like this you'll find out A1. Understood? Only this concept was there, conservation of momentum. When at the mean position just before small m is placed and just after small m is placed. Because no extra force is acting. What happened with this? Velocity has changed after the attachment of small m, and after attachment the omega also changed. It became omega 1. Now the total mass is small m plus capital M, so the frequency will be root over k by capital M plus small m. Initially it was k by capital M. Understood? What, Haripriya, Diva, understood? Kanishka?
Yes.
Hmm.
Yes, sir. This question is completely different.
This question was different. That's why I gave you. So then now we will be able to solve it. The answer, I think, answer will be you will be getting is B.
It should be B.
A1 will be equal to A root over capital M by capital M plus small m. Okay, let's end it. Next class we'll solve some more questions, then we'll move on to the next chapter. But I want some questions to be solved in the next class so that you become comfortable.
Bye, sir.
Bye bye.